everyone, this is lesson 2.7, solving proportions. Today we're going to learn how to use the cross product to solve proportions and write and solve proportions for real-world problems. So this lesson is very similar to 2.6, but we're just taking it a step further, and you're going to see that the variable sometimes is in the denominator, or there are variables on both sides of the proportion, or in the numerator or denominator, there's an expression rather than just a number or a variable. So let's do just a simple warm-up question, and make sure you're taking notes and writing these problems on your paper in your notes, because there will be a mini quiz over two of the questions that are from this lesson. So make sure you're writing down the questions carefully and listening to the whole explanation so that you get the right answer. All right, so first of all, there are a couple ways we can do this. The way we learned in the last lesson is to multiply by 21 on both sides and simplify. Okay, the other thing that we can do is notice that 32 over 28 can actually be reduced. And a lot of times if you do that step first, it'll make the rest of the question a lot simpler. You might even be able to do this in your head. So 32 and 28 both go into 4, so that would be 32 over 4 is 8. 28 divided by 4 is 7. So then it comes to n over 21 equals 8 over 7. And then now what we can actually do is use comparison with the fractions. So 7 times 3 gives us 21. So that means 8 times 3 gives us 24. So n is equal to 24. Okay, and then just a simple question here. How are proportions related to scale drawings such as artwork or maps? So you can think about the question, scale drawings, for example, might be a ratio of 1 to 4. So the actual image is 4 times the image that you're drawing. And in maps, you'll often see like a 1 inch on the map represents 1 mile, for example. And then artwork, I know that you guys use scale drawings in artwork, and when you're creating artwork or a scale drawing, the sides of what you're drawing have to be proportional. So you have to have the same proportion throughout, or else it's not going to look like the actual image. So if I'm drawing a face, for example, I don't want the eyes to be like that big, right? That looks kind of creepy, actually. You want the eyes to be proportional to the face. So, maybe that big. I am not an artist. Anyways, you get what I mean. So let's look at some other examples. So these examples, we're going to use the cross product, which I'm pretty sure you're familiar with. So the idea of the cross product is, remember how we learned to multiply both sides by what's in the denominator? So really you're multiplying both sides by both denominators. So you're going to multiply both sides by x and both sides by 15 at the same time. So then what you're actually doing is you're taking this 15 and multiplying it by that numerator, and this x and multiplying it by that numerator. So then you get 8 times 15. Oh, what's 8 times 15? Well, 4 times 15 is 60. So 8 times 15 is 120. So 120 equals 6x. And then to solve for x, you just divide by the 6, and you get 20. Okay, another way we could have done this is to first simplify 6 over 15, and that would have made our problem a little bit easier. So let's try that in number 2. Let's simplify 12 over 24, which is 1/2. So then you have 4 over x equals 1/2, and let's use the cross product. So you can compare if you want. I'm just going to practice with cross product. So 4 times 2 is 8. 1 times x is x, because we're going to get to a point where you're not going to be able to compare. So we'll just practice using the cross product now. Okay, so here, and I'm going to make a note up here, to simplify or reduce first. So we can reduce 24 over 30. They both go into 6, so that'd be 4/5. Okay, so here, if 4 over a equals 4 over 5, then we really don't need to do that much for this problem. You can easily see that a has to be equal to 5. All right, some more complicated equations. So solve proportions with grouping symbols. So here, let's use the cross product. So you see how you have this x minus 3 here? So we have to take 4 times x minus 3. Now, when you do that, you have to put the x minus 3 in parentheses so that the 4 is not just multiplied by x, but it's multiplied by the whole thing. And then equals 8x. Always write the coefficient before the variable, right? And then you have an equation similar to what you saw in 2.5, where you have to have x on both sides of the equation. You have to distribute the 4 to get rid of the parentheses, so 4x minus 12. Subtract the 4x. So you have negative 12. I'm going to write it up here. Don't forget to include the sign that's in front of that number. Equals 4x. Divide by 4. And you get x is negative 3. Okay. This question. Let's do the same thing. Do the cross product. So m times 4 is 4m. And then 5 times m minus 6, putting m minus 6 in parentheses. So we have 4m equals 5m minus 30. Draw your arrows if you need to. And then, the way I taught you is to move the smallest m over to the other side. And you can still do that here. The thing here is you'll just have 0 on this side. And that's okay, because now what we're going to do, so 5m minus 4m is just 1m, is add the 30. So then it's just 30 equals m. All right, number 3. So let's use the cross product. So 18 parentheses d minus 13 equals 6 parentheses d plus 13. Okay, use the distributive property. So 18d minus, type that in your calculator, 18 times 13 is 234, equals 6d plus 6 times 13 is 78. All right, so let's combine some like terms here. So let's subtract the 6d. And I'm also going to add the 234 at the same time. Okay, so then you get 12d equals 78 plus 234 is 312. Divided by 12 on both sides. 312 divided by 12 is 26. All right. Now for this next one, I'm going to go ahead and let you try it. So pause the video and try it yourself. All right, so at this point, you should have already answered the question. So let me show you real quick how you would do it. I'm not going to do the whole thing. I'll just show you the first few steps. So you have 7 times x plus 18 equals 21 times x minus 14. Distribute. So you get 7x plus 7 times 18 gives you 126. And 21x minus 21 times 14 gives you 294. Okay, so at this point you can figure out what you need to do to get the answer, which was x is equal to 30. Okay. All right, so now for some word problems. So number 1, since the diameter of the burst of a firework is proportional, okay, that's a key word here, and that tells us that we're going to be setting up a proportion for this problem. So the diameter of the burst of the firework is proportional to the diameter of the shell. So we have the burst diameter over the shell diameter. Okay, that's what that means, that first sentence. Use the information in the diagram to write a proportion and find the burst diameter for a 4.75 inch shell. Okay, so let's write a proportion for this drawing. This is the information that we know. So the burst is 90 feet and the shell is 2 inches. Now, since these are different items, they don't have to be in the same unit. Okay, so equals, and we're trying to find the burst diameter, so x feet over 4.75 inch shell. All right, so as you can see, for a question like this, you really can't use comparison. The easiest way to do this would just be to use the cross product. So 90 times 4.75 gives us, I don't have my answer on my paper. Let's figure it out. 90 times 4.75 is equal to 427.5. So 427.5 equals 2x. By the way, it doesn't matter what side you put either of these on. It's okay if you have this flipped. Okay, and then divide by 2. So then x is equal to 213.75 feet. Okay, now what you might want to do is ask yourself, is my answer reasonable? So if this is 2 inches and ours is 4.75, theirs is 90 and ours is 213. So it's a little bit over twice as much, and 213 is a little bit over twice as much as 90. So yes, it does make sense. So always ask yourself if your answer makes sense at the end. Okay, let's explore a chemistry concept called moles. So a mole is a unit of measurement in chemistry. You'll learn about this when you take chemistry at the high school, or if you take AP chemistry. The masses of 1 mole of 3 elements are in the table here. A 100-gram sample of ascorbic acid contains 4.58 grams of hydrogen. So here's the hydrogen. And then, so this is 1.008 grams. To the nearest tenth, find the number of moles of hydrogen. All right, so a 100-gram sample of ascorbic acid. So here's how we're going to write it. So we have 1 mole to 1.008 grams of hydrogen. 1.008 grams of hydrogen. Make sure you include units. And then equals, we're trying to find how many moles are in hydrogen, which has 4.58 grams. So x moles over 4.58 grams. So actually, it turned out that this 100-gram sample was really not necessary to solve the problem. All right, so let's use the cross product to solve. So 1 times 4.58 would be just 4.58. And then this would be x times 1.008, so 1.008x. Divide both sides by 1.008. Type that in your calculator, and you get 4.5 moles. Make sure you include units. All right, how about this one? So again, it contains 45.5 grams of oxygen. To the nearest tenth, find the number of moles of oxygen in the sample. So we're going to set up our proportion the same way. So 1 mole over 1.00, wait a minute, hold on a second. 1 mole, we're using oxygen here. So what's the number for oxygen in the table? It was 15.999 grams. So 15.999 grams of oxygen, O stands for oxygen, equals x moles in our sample over the 54.5 grams of oxygen are in our sample. Okay, so now I'm going to let you solve. It's the same way you solved up here for part A. So if you pause the video, then you can solve the problem. Okay, so if you cross multiplied 54.5 grams of oxygen equals the 15. Now I'm running out of room here. 999 grams X, and then divide both sides by the 15.999, and 54.5 divided by the 15.999 would be 3.4 moles. Okay, so now what we're going to do is just an example on scale trolleyings. Okay, we're going to skip this here. Okay, so the ship model kits sold at a hobby store have a scale of 1 feet to 600 feet. A completed model of the Queen Elizabeth is 1.6 feet long. Estimate the actual length. Okay, so the scale is 1 to 600. So our model, and obviously the 1 is for the model and the 600 is for the actual length. So our model is 1.6. The actual length is what we're trying to find, X. So then you would use the cross product. 1x equals 1.6 times 600. 600, which ends up being 960 feet for the actual length of the Queen Elizabeth II. Okay, number 2. A map has a scale of 1 centimeter to 15 kilometers. Find the actual distance given the map distance. So once again, we'll write our ratio here. 1 centimeter over 15 kilometers equals 6 centimeters over x kilometers. Okay, so write the cross product. So we would have x is equal to 15 times 6 gives us 90. And this would be 90 kilometers. All right, and I'm hoping just from these 2 examples you get how to set up this question. It would just be the same thing. 1 over 15 equals 4.7 over x. Okay, now I'll let you just do that one on your own. All right, so that is all for today. Have a great day.